Hi there, and welcome to this video on A-Level Chemistry for the AQA specification, focusing on the topic of kinetics and in particular on temperature. Hi, I'm Manisha from StudyMind, where we help you to revise A-Level Chemistry with our helpful revision resources tailored to your subject, your specification, and to you. If you're new here, please make sure to click that subscribe button, and whilst you're watching, please leave any comments down below about anything you're unsure of. If it's your first time watching, make sure to let us know so we can send you our free revision resources. We also have helpful timestamps to guide you through the video. So, let's get started. Welcome to lesson 3 of 5 in this tutorial, covering the effects of temperature on reaction. This is the third video in our series of 5 lessons on the topic of kinetics. In the last lesson, we looked at the Maxwell-Boltzmann distribution of molecular energies in gases. Here are the key learning objectives for this lesson. First, we will cover the rate of reaction, and then we will look at its relationship with temperature. Here are the AQA specification points for this section. We'll start off by defining the rate of reaction. The rate of reaction is defined as the change in the amount or concentration of a reactant or product over time. It is defined as the decrease in the amount of reactant over time, and can also be defined by the equation shown here. This is the short version, which is still acceptable to use in AQA exams, as long as you know what the symbols stand for. Here are the units for this reaction. The units can look rather complicated, but they are simply moles per decimeters cubed per second. Can you name the factors affecting the rate of a reaction? If not, don't worry, we're about to go through them here. The rate of reaction is influenced by many factors, including temperature, pressure, the presence of catalysts, concentration, and surface area. Today, we're going to be focusing on temperature, but in the next video, we will look at the effects of pressure and concentration. Let's move on to our next specification point, covering the effects of temperature change on the rate of reaction. An increase in the temperature will cause particles in a reaction to move faster as they gain more kinetic energy. As the particles gain more kinetic energy, a greater proportion of the particles have more energy than the activation energy. In other words, the particles will possess at least the activation energy needed to react. This leads to an overall increase in the rate of reaction. Now let's look at a flow diagram to describe the effects of temperature changes. An increase in the temperature will cause the particles to gain more kinetic energy. The particles will move faster, leading to more collisions per second and more successful collisions per second. A greater proportion of these particles will have energy that is greater than the activation energy. In other words, the particles will possess at least the activation energy, which means they will be able to react. There is an increase in the number of successful collisions, and therefore the rate of reaction will increase. As we can see in this diagram, there are more high-energy particles on the right-hand side compared to the left-hand side. This is due to there being a higher temperature on the right. At a higher temperature, as we've just seen, there will be more collisions per second, and there is also a higher energy per particle. As the temperature increases, the rate of reaction with enzymes will also increase until a certain point. This is due to some of the enzymes
which are biological catalysts, becoming denatured. Remember, it is only the collisions that possess at least the activation energy for a reaction that result in a reaction. You should always explain your exam answers in terms of collision theory and the number of successful collisions. It can be very useful to draw diagrams wherever you can. Now, let's cover the drawing of distribution curves. This figure shows how a Maxwell-Boltzmann distribution will change at different temperatures. You should be able to explain why the rate of reaction increases when the temperature increases by using the Maxwell-Boltzmann plot to help you. Here, we can see two temperatures, T1 and T2. T1 is a lower temperature than T2, and we can see the shaded area on the graph to the right of the activation energy is the number of particles able to react. At T2, however, the peak of the curve is both lower and shifted to the right. We can see that the area to the right of the activation line is greater under the curve at T2 compared to T1. This means there is a greater fraction of particles with enough energy to react. Let's look at our final specification point, covering temperature changes and increase in rate of reaction. According to the Maxwell-Boltzmann distribution, increasing the temperature increases the proportion of particles that will have sufficient energy to react. This can be observed from the shaded region, which increases in area when the temperature is increased. As a result of there being a greater proportion of particles having sufficient energy to react, the rate of reaction will also increase. The graph shows that even a small increase in temperature will lead to a larger increase in rate. For both temperatures, the area under the graph will stay the same. The area under the graph will represent the total number of molecules in the reaction. We know that the total number of molecules in a reaction will always stay the same. We've now covered all the specification points for this section. Feel free to skip back through the video and re-watch any of the sections that you are unsure about. We have now completed Lesson 3.
If you liked this video, make sure to catch our latest videos by subscribing down below and leaving a comment on a topic that you'd like to see a video on. Click here to watch more videos on our series of A-Level Chemistry, or visit our website studymind.co.uk for past paper compilations by topic and specification.